Okay, so welcome everyone to this Maths Volunteer Annual Test 2024. And these are some guidelines. First, play seriously and give serious answer because we will award top 5 students with certificates of appreciation. And so with this test, you all can check your knowledge, level up your knowledge, and also it will help you prepare for admission tests or like other jobs test. In the test, there are some MCQs and some true false questions as well. For each question, the time will be assigned according to the level of difficulty. And the quicker you answer to a question, the more points you will earn. And after each question, one of our member, or particularly Shapesel, will explain the answer when it's too difficult or when a lot of people choose the wrong answer. And at the end, you will also have your overall score. So let's go to question number 1. Okay, very good. Most of the students got the correct answer. Yeah, there is the podium. And now we go to the slide where we have the explanation. Shah, would you like to say a few words or it's straightforward?
Yes. So there is a theorem in real analysis that says that if you have a continuous function defined on a closed interval, then the function attains every value between its extremes. So if you look to this function f of x, which you define exactly by the given equation, then you plug 0, so you get 1. That's a positive value. And if you plug pi by 2, then you get a negative value. So by that theorem, 0, since 0 is between 1 and something minus, therefore, there would be a point in the closed interval where the function would map it to 0. So the answer is exactly what you get from this theorem.
Yeah, very well, thank you. Let's go to the next question. Wow, that's quite a diverse response. and let's see. Okay. Yeah, we have a new top candidate. Let's go to the explanation. Yeah, Shah, would you like to say a few words or?
Right. So the question was actually giving a definition. So you can find spaces where the limit is unique, but there are none of these. So the correct answer is none of these. So that's basically it.
Okay, very well, thank you. Let's go to the next question. Very well. Okay. So that's encouraging. Let's go to the podium. Diversity. Let's go to the explanation. Yeah. Shah, would you like to say?
Give me 1 minute. There is Azan.
Sure.
Okay. So well, there is a, a,
Shah, your voice
simple
is a bit.
theorem that function if
Shah, could you say again what you
what?
just said, because your voice was interrupted?
All right. So if you have a smooth function, then it is constant if and only if its derivative is 0. So you just differentiate the function with respect to z as you see in the picture, and then you get 0 for all of them. I mean, it's a simple thing. You can just see that sine square plus cos square equals 1, and so it's constant for any value. But in general, you would like to compute the derivative and then see if this is constant or not.
That's great. Okay. Thank you. Very well. Simple but computational. Wow. I see a lot of guesses there. Okay, let's go to the podium. Great. Well done, Nemra. And yeah, that's.
Yeah, I think the time given for this was a bit I mean, less than what I was expecting, because one has to compute something. So by definition, you would call 3 integers Pythagorean if you have this equation that if you square 2 of them and add it, then it adds up to the square of the third one. So it's just computing, and you see what the correct answer is.
Right. Thank you. Not what I would expect, but let's go to the podium. Yeah, that's that. And let's go to the explanation. Yes, sure.
Okay, so a null set in measure theory is a set which has zero measure with respect to a given measure. And here we meant the Lebesgue measure, so it should be understood. And uncountable is something, is a set that you cannot put in bijection with a subset of the natural number. So it's known that rational numbers are countable, so that's not the correct option. And algebraic numbers are by definition numbers which are the zeros of some polynomials. And it's a theorem that they are actually countable as well. So the answer, the Cantor set is basically the correct answer. It has measure 0 and it's uncountable.
Okay, thank you. Let's go to the next question. Well, again, a lot of diversity in answers. Let's go to the podium. Very well, Mujahid. And then let's go to explanation. Yeah, sure.
Okay, so Borel sets are basically coming from Borel algebra, which is basically sigma algebra generated by open sets in a given topological space. So Borel set in general would be closed or open, or their combined intersection and so on. So Cantor set is a closed set by construction, so it's Borel, but and rational number, you know, that's also close. I mean, it's a union of closed sets, the singleton set, and therefore the correct answer is none of these.
Very well, sure. Let's go to the next question. I think this question here is more time than it was difficult. Okay, very interesting. Let's go to the podium. Very well, Binish. And yeah, the explanation. Sure, please.
Okay. So how do you compute the complex exponential, or the logarithmic? You have this thing you have already maybe seen in somewhere, and where the log of a complex number is defined this way. So you just plug the value of z to be 1 plus iota, and there you go. You would get this computation. So you just look to the screen and read it yourself.
Yeah, yeah, that's very pretty straightforward. So thank you. Let's go to the next question. Very well. Good, Sidra. Yeah, let's go to the explanation. Shah.
Okay, so it's a famous theorem, Fermat-Little theorem. It says if you have a prime number p and then an integer a, then that integer a to the power p minus 1 is congruent to 1 mod p. So that basically means that if you divide a to the power p minus 1, then the remainder is 1. That's another way to say it. So here you take p to be 17 and a to be 6, and then you get 1. So the remainder, whatever, is 1.
Very well. Let's go to the next question. Well done. That's encouraging. Very well, Mujahid. Yeah, Shah.
So there is a theorem which says that if you have a finite dimensional subspace and you have a sequence that converges somewhere in the full space, then the limit point doesn't jump to somewhere else, so it stay in the subspace. So that's what we mean by closeness. So you just need to remember that theorem. So the answer is closed.
Yeah, diversity in answers. Very well, finished. Yeah, let's go to explanation by Shah.
Okay, so a Hilbert space is an inner product space which is complete. Okay, which is a complete metric space. And convex set, we mean that if you take 2 points, then the line joining the 2 point completely lies inside. And there is a theorem. Well, you don't need that theorem to answer this, but it says that if you have a convex set, then you can find a unique element of minimal norm. So here you don't need convexity for the existence, but for the uniqueness of that point, you need convexity. And to answer this question, you just look to R2, the Euclidean space, and the first quadrant as a convex set, then you see that there is no largest element because it just go to infinity. And the second option equal doesn't make sense. So you can just even guess from this counter in this specific example.
Very well, Shah. Let's go. Okay, that's good. It's encouraging. Well done, Dildar. Amazing. Yes, Shah.
Okay, so in your function analysis beginner course, you have seen that if you have an inner product, then it gives rise to a norm, and that norm satisfies this parallelogram equality that is written on the screen. And it turns out that if you are given a norm, then to see whether it comes from some inner product or not, is to just check the parallelogram equality. And a norm comes from an inner product if and only if it satisfies this equality. And if you see the LP norm, you just plug everything in this equality, and you will see that P has to be equal to 2 in order for the LP norm to satisfy this equality. So L2 is the only situation where the norm comes from an inner product.
Very well, Shah. Let's go to the next quiz. Well, I can see some guesses there, maybe random. So that's the podium. And let's go to Shah.
So if you have two functions here, f and g, and you want their composition to be bijective, then g has to be injective, because if it maps two different points to a single point, then the composition would actually map. F has to be injective, because if it maps 2 points to a single point, then the composition would map those two different points to a single point as well. And you want surjectivity, so G has to be surjective in order to cover the whole codomain. So the answer is F has to be injective and G has to be surjective.
Very well. And let's go to the next. Wow, that's amazing. Let's go to the podium. Well done. And then we go to Shah.
So what is wrong is that every bounded function is Riemann integrable, and there are counterexamples. Well, you just look to the answers and you see that the other options are correct. So the only one that could be wrong is this one. The Dirichlet function is a bounded function which is not Riemann integrable.
Yeah, very well elimination strategy. Let's go to the next one. Encouraging. Very well, Hamza. And let's go to Shah.
So a linear differential equation is an equation which doesn't have terms which are nonlinear in the dependent variable. So for example, here the first one is sine of y, which is a nonlinear function of y. And then the second one has product of y with itself. So it's y squared. So that's not the case. And the correct one would be the third one, which has no nonlinear term of y.
Very well. That's good. Nice. Shah, would you like to say a few words?
So orthogonal matrices, they preserve the length of vectors, and eigenvalues measure how much the matrix stretches things. So if you take an eigenvector, then you can write down the image of that as a multiple of its norm by the modulus of the eigenvalue. And if you want the length to be preserved, then the eigenvalue has to have modulus 1.
Very well.